Robert?
Hey big fella, talk to me.
Okay, this is part 2 of our final year project sensors. What I've got here is a Parallax ping ultrasonic sensor. It's about a $45 sensor from Little Bird Electronics that we've purchased. It's got three inputs. You've got ground, 5 volts for just to operate it, and you've got a signal. The way the signal operates is you send it a 5 microsecond pulse, and after a short period of time, I think it's about 20 microseconds, it'll send a pulse back, and the length of that pulse will vary. Like, it will go up and it will stay for as long as it, and it will vary. The length of that pulse will vary depending on how far the object is away from the ultrasonic sensor.
Okay, sure. Do you want to show me more about it rather than just talking about it?
Okay. As you can see, I've got it hooked up here. We've got the initial pulse here, right? As you can see, it's very tiny, and then you've got the reaction wave. Now, I've got the sensor on the table pointing at the roof, and it basically gives you a pretty firm reading of how far it is away from the roof. Now, if I get James to do that, and I'll take it towards the roof, you'll see that it's quite linear in its response. So if I just pick it up, I'm moving at a pretty constant rate. Oh, just got to move that cable. And that's about as far as the cable will let me go. Right.
So bring it back down to the table. Take it to the ground. So how far would you say that is from the ground to the roof?
It's about 2.5 meters.
Okay, no problems. Okay, well, how about we try and do something a bit different? How about you try and angle it at the roof? So just put on this angle.
I've got it at about my belly height from the roof, which is about, it's picking up off the light. I've got it from about belly height to the roof, and that's about a meter.
Yeah.
So what I'm going to do is I'm going to start angling it.
Show us an example.
Like this.
Yep.
Right. Just give you an idea on the response.
Okay, well, call out the angles as you go.
Just move it over a little bit more. Okay, so you got dead on.
So perpendicular, 90 degrees.
That's 90 degrees. So you got about 80 there. That's about 70, and that's about 60 degrees. So you notice at about 60 degrees, it tends to lose its response. So in terms of reflection, you've almost got to be dead onto it for it to respond. And that's one of the pitfalls of this type of ultrasonic one. And it's now picking up off the back wall. So I'll go back. So I've got 90, 80, about 70, and just past 70, that's where it triggers. It seems to pick up off something else. I'll go even further. That's about 45. Probably not, but it's about 40. 30. I think my angles are a bit screwed, but that's 90. Now it's picking up off the wall. So yeah, as you can see, it's got a bit of a step there. And it's kind of hard to gauge exactly what's going on.
So how do you feel about this sensor being used in the mobility aid?
Look, we can use it, but the problem is like,
what would it be useful for then?
The idea of having it is having it so it's pointing out this way, and if it's not going to pick up an overhead obstacle that's like at this kind of angle to it, it's pretty much useless. We need something that's going to be able to, if it can reflect the image back. If it was hitting off a wall like that, yeah, it'd probably work. It'd be ideal as a straightforward sensor more so than a straight up and down one.
Okay.
Or taking off at a 45.
How would this sensor work if it was being swayed? Is the frequency fast enough?
It's fast, plenty.
But is the accuracy fast enough too?
Being swayed. Okay, let's have a look here. All right. Alright, so I'm moving it as a blind person across the roof, and
it's doing a bit of a hop in the middle.
Yeah, it's got a little bit of a hop in the middle, but mind you, that's not bad for what it is. I'd be pretty happy with that, and I'll swing it even faster.
So you swing about Oops.
And it's just disconnected.
Oh well, that's what you expect from John.
Oh, thank you. I'll make sure I put it back in correctly. Brown on the left.
Don't let the smoke out, John.
Always the brown on the left. So the response from it's very quick. That's what I'd expect from a high quality sensor like this particular one here. And really nice thing about it, it's got all the circuitry on board. So all basically you have to do is send the minimalist of signals to it to make it operate.
How does the signal work on this one, Joel?
I described that at the start of the video.
No, as in like the direction of it.
Well, the pin's an input-output pin. So basically, you send the microcontroller that we've got sitting here, which is the same as the previous video, which is the AC12.
Mm-hmm.
We've modified our regulator from 3 volts up to 5 volts because that's what the sensor requires.
Mm-hmm.
What do we change? So basically, the HC12 sends a signal out to this 5 microsecond pulse.
Mm-hmm.
It waits a second, and then you get a response. It waits a small fraction of time, as you saw here on the scope,
mm-hmm.
and then it sends a response back to it.
So it gives up control and actually uses the same pin as an input.
Uses the same. It's got an input-output pin.
Yep. So it's bidirectional, whereas the laser was just unidirectional.
That's right.
So in that regard, it's actually less pins.
That's right. There's less pins all over. And
Okay.
you don't. The good thing about this particular one, timing is very critical. So your measuring of your timing between the bigger poles is very critical. Not so much on the LPDA because you can count it off clock steps. And for the infrared one, it didn't require any input at all, but it required analog interpretation.
Okay. Was there anything else you'd like to add?
I'm a little bit disappointed in the angle that this thing reacts at. I thought it would have given a slightly better angle.
Mm-hmm.
If that was the case, it'd pick up a lot more stuff.
Yeah.
It's very unique in its view. Like if I hold that there, I'll just take my fingers like this, and it's reacting about there. So that's about.
It's a very broad.
It's a very broad angle.
Okay. And not only that, it seems to be picking off bounces off walls, as in like indirect. So it actually bounces around the room a bit.
Yeah.
And detects off other bounces.
Well, you could say that, yes. But yeah, as a long-term as a distance sensor, it is probably one of the most accurate sensors we have.
Okay.
Because the response is very linear.
Mm-hmm. It's a linear response. Yeah.
I can hold it back here, and it's very proportional. Like if I go from here to here to here to here, the distance on the scope is very proportional.
Yep.
Whereas with the LPDA, it was very logarithmic.
Mm-hmm. Mm-hmm.
It was a bit harder to gauge.
Yep.
All right. I can't think of anything else.
Would you like to thank anyone?
I want to thank Peter O'Donoghue. All the inspiration you give me. Thumbs up, bro.
Mm-hmm. How about your mum?
Sure, why not?
I'd like to thank my mum. Because without her, I wouldn't be alive.
Straight back at you.
Thanks, Joel. So what are you going to show us next after this?
Next up, I've got a Sharp infrared sensor. So we'll describe all about that in the next video.
To be continued.
Cheers.